Oke, tadi kita udah mulai simak mengenai materi tentang teori Lagrangian Interpolation. Sekarang kita masuk sesi kedua, di mana kita akan mengimplementasikan Lagrangian Interpolation ke dalam sebuah kasus. Oke, tanpa berlama-lama lagi, ayo kita langsung cek. Oke, teman-teman, sekarang kita masuk ke example dari Lagrangian Interpolation. Kita langsung simak aja ya videonya.
In this segment, we're going to take an example
Oke, videonya lumayan,
for
10 menit.
Lagrangian interpolation. So the example which we are taking is the simplest example of linear interpolation.
Oke.
So let's suppose somebody is giving you the data like this one.
Ya, sekarang kita masuk ke kasusnya, di mana diberikan sebuah data ya.
They're giving you velocity versus time for a rocket.
Ini apa? Ada tabel dengan kecepatan
Time is given in
dan
seconds,
waktu.
velocity is given meters per second.
V ya, V, velocity.
And these are the numbers which they
T,
give you
waktu,
that
time.
at time t equals 0, velocity is 0. At 10, it's 227.04. At 15, it's 362.78.
Satuannya meter per second ya, di mana ini ada detik ke 10, 227,04 dan
At
seterusnya.
20, it is 517.35. At 22.5, it is 602.97. And at 30, it is 901.67. So the question which is being asked is that you are given this data here. So given this data here, you're asked to find the value of the velocity at 16.
Oke. Nah, di sini diberikan data dengan kecepatan dan waktu yang sudah ada di gambar. Pertanyaannya adalah kita diperintahkan untuk mencari kecepatan ketika pada detik ke-16.
So we know that since we are given 6 data points, but we are only conducting linear interpolation, so that's the part of the example statement that you need to conduct linear interpolation. We're going to choose the two closest points which are to 16.
Jadi kita akan memilih dua data poin yang terdekat ya. Terdekat dengan 16. Situ ada 15 dan 20.
And 20. But at the same time, they also have to bracket the number 16. So the two numbers that you're going to select for linear interpolation not only have to be closest to the point where you are interested in finding the intermediate value, but also they have to bracket the point itself. So what that means is that we have chosen two data points for our linear interpolation, and we want to conduct this linear interpolation based on the two data points which you have chosen. So I'm going to write those down. I got 15, 20 are the times. The values are 362.78.
Oke, ini ditulis ulang ya.
The value here is 517.
Pada detik 15 dan 20 kecepatannya gimana?
Based on this, we already know that the velocity now should look like, so far as the Lagrangian polynomial interpolation is concerned.
Kita akan menggunakan rumus yang sudah dibahas pada segmen sebelumnya ya.
To n L sub i t v sub i.
Baik, weighting function ya, ini LI.
T. V of t sub I. So it is the weighting function multiplied by the value of the velocities at the different points which you have chosen. And since n is equal to 1 in this case, because we are choosing a linear interpolant, so it's an order of polynomial 1, with L sub I t, v of t sub I. And if I expand this, I'm going to get L naught of t times v at t sub naught plus L1 of t times v sub t1. So basically,
ini di breakdown ya, dimana menggunakan L0 dan L1 ya.
You have two values of the velocity at T0 and T1, and you're giving them a weight of L0 of T here and L1 of T right there. And what is T?
Kenapa ditambah dan kenapa berulang? Ya ini penggunaan sigma ya teman-teman. Berhubung ini dari I 0 sampai dengan 1 sehingga jumlah iterasi operasinya itu 2.
T0 and T1, this is T0 and this is T sub 1. It won't matter
Untuk
if you switch
mempermudah
it. That's something which you do need to
deklarasikan T0 T1
And this one here is the
dan
value of the
ini
velocity at T0
V
and this one is the value of
T0 dan V
velocity
T1.
T sub 1. So we have everything which we need, and all we have to do is to calculate what
Sekarang ini udah semua yang dibutuhkan untuk perhitungan sudah ada. Sekarang kita tinggal mengkalkulasikan.
these individual numbers are for L0 of T and L1 of T. So what I'm going to do is I'm going to write down here L0 of T times the value of the velocity at 15 plus L1 of T
Sekarang udah mulai
times the
dimasukin ya
value of velocity
nilai-nilainya.
at 20, because those are the values of T naught and T sub 1. So this gives you L naught of T, V sub 15 is 362.78
Oke.
plus L1 of T
Langsung
times the
disubstitusikan ya
value of
nilainya.
velocity at T sub 1 is 517.
Ini operasi perhitungan
So
yang
let's go and find out
biasa
what these
kita operasikan.
two Lagrangian weight functions are, so that
Oke. Sekarang ini sudah disubstitusikan nilai velocity-nya. Sekarang kita tinggal mencari nilai weighting function-nya.
we can complete this particular interpolant here. So the first one is L naught of T.
Oke.
So
Sekarang mari
L
cari.
naught of T will be equal to the product going from J equal to 0, J naught equal to I,
Oke.
all the way up to N, which is 1 in this case. Okay. Times T minus Tj divided by T sub I, which is I is not 0, minus T sub j. So if you look at the original formula which I have, this comes from pi j equal to 0, j
Oke, dia
naught equal to
mencoba
I,
menuliskan
equal to
rumus
n is 1,
rumusnya ya.
T minus T sub j divided by T sub I minus T sub j. That's where all of this is coming from. And since I is equal to 0, that's why I have 0 here. Since n is equal to 1, linear interpolant, we have a 1 here. So what this means is that we're going to get t minus, when I take j equal to 0, I'm going to get t minus t sub naught divided by t naught minus t sub 1. Okay. Sorry, this will be t sub 1 right here.
Ini ada kesalahan.
Because
Oh ya.
when j is equal to
Harusnya
0,
sama
j
ya.
is not equal to I, so I cannot choose j equal to 0.
Oh,
I cannot choose j
J
equal to
tidak
0
boleh sama dengan
because
I.
I is equal to 0, so that's why this term is not going to be taken. So when I was saying I'm taking j equal to 0, I cannot take j equal to 0 because I have I equal to 0 there. So the next term will be j equal to 1, so that's why I have t minus t sub 1 and t naught minus t sub 1. Now L1 of
jelas ya teman-teman. Jadi kenapa dia J-nya tidak mengambil dari 0? Karena I-nya itu sudah bernilai 0, sedangkan aturannya itu I tidak boleh sama dengan J, sehingga J-nya ditambah 1.
t, which is the other weighting function, will be going from, again, j equal to 0 to 1, j not equal to I minus t sub j. So the only difference with the previous expression is that now you have instead of 0, you have 1 now, so you're going to 1 here.
Oke.
Now, what you're going to do is you're going to start from j equal to 0, which is not equal to I, because I is 1. So that means that I got to put j equal to 0 here. I get t minus t naught divided by t.
Oke. Nah ini J-nya baru diisi nilai 0 karena I-nya itu bernilai 1. Jadi tidak sama ya. Jadi
1
diperbolehkan.
minus t naught. Now I cannot, the next term, which is j equal to 1, is the same as I equal to 1, so that term will not be written there. So we only have a single term there. So that gives us the weight for L sub 1t, and that gives us the weight of L naught sub t. So I'm going to substitute it back into the formula which I had previously.
Coba disubstitusikan
So I have V sub t
ke formula yang tadi ya.
To L naught of T times
Dengan kondisi sekarang L0 dan L1 sudah
V of
diketahui.
T naught, which was 362.78. 362.78 plus L1 of T times the value of the velocity at 20, which was 517.35. And now I'm going to substitute these weights, so I get T minus T1 divided by T naught minus T1 times 362.78, then plus T minus T naught divided by 0.35. And you will see that now I can substitute these values. I get T minus T1 is 20.
Nah, ini udah mulai dimasukin ya.
Which is 15. T1 is
T1-nya 20, T0-nya 15.
Plus T minus T1, which is 20, T naught, which is 15, times 517.35. So that's going to be my my Lagrangian interpolant. If you want to write it in that particular form and maybe give it a little, try to simplify it if you want to. And it will be valid between 15 and 20 because those are the two endpoints.
Jadi formula ini bisa digunakan untuk data dari kecepatan dengan detik antara 15 sampai 20. Jadi apabila kita mau cari yang 17, 18, 19, tidak usah menghitung ulang, cukup menggunakan yang ini ya, perhitungannya. Kita tinggal mengganti T-nya saja nanti.
But we are interested in finding the value of the velocity 16, so we don't need to necessarily simplify this expression to find the value of the velocity 16. We can directly substitute 16
sekarang
into
T-nya diganti
the expression.
Dengan nilai yang kita cari, 16.
And we get 16 here. And the number which I get for the interpolant at t equals 16 will be equal to 0.8 times 362.78 plus 0.2 times 517.35. And this number here turns out to be 393.69 meters per second.
Oke, hasilnya adalah 393,69 meter per second pada detik ke-16.
By using Lagrangian interpolation. And that's the end of this segment.
Oke, pada contoh ini kita diberikan sebuah data, tadi kita coba review lagi ya. Berikan data, nah kita pada example ini mencari pada kecepatan, berapa sih kecepatan pada detik ke-16. Nah, di sini kita mengambil data 15 dan 20. Setelah kita lakukan perhitungan, VTI-nya sudah diketahui, yang kita cari kemudian adalah weighting function. Di sini ada penjabaran weighting function. Nah, hasil penjabaran weighting function ini setelah disubstitusikan angkanya seperti ini. Nah, setelah ini angka atau formula ini, weighting function ini bisa digunakan untuk detik 15 sampai ke 20. Jadi kita tidak perlu menghitungnya ulang. Hingga ditemukan nilainya 393,69 meter per second pada detik ke-16. Oke. Bagaimana mudah ya teman-teman? Jadi kita melakukan perhitungan biasa, memasukkan substitusi nilai, kemudian menghitung weighting function, dan kemudian dikalkulasikan. Oke, mungkin sekian implementasi dari formula Lagrangian Interpolation. Saya Andi Fauzy. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.